Hi everyone, it's Mrs. Bebo. In this video, we're going to take a look at writing and solving one-step equations. So our main goal for this video is how do I solve one-step equations? We're also going to take a look at a few story problems as well. So vocab, really important, knowing what an equation is, which is a sentence stating that two quantities are equal, and it contains an equal sign. So that's the difference between an expression and an equation, right? So an equation is going to have that equal sign, an expression is not. And a solution is a value that makes an equation true. So that's what we're looking for today as we go through and solve equations, is what is that value, that solution that makes this statement, this equation, true. So to solve equations, we can use these properties of equality. And essentially all this table is showing us is that if you do one operation to one side of the equation and you do the same thing to the other side, the overall value of the equation is going to stay the same. So it's really important when we solve equations, do the same thing to both sides. If you're adding a value to one side of your equal sign, you better do the same thing to the other side. Same with subtraction, same with multiplication, and same with division. So those properties of equality not only help us with these one-step equations, which I like to call, little baby equations, they're going to help us with those more complicated ones later on. So it's really important that we keep these properties in mind and show our steps as we go through that we're doing the same operation of both sides of our equation. Another piece that's important as we work with solving equations is the inverse property of multiplication, knowing that the product of a number and its multiplicative inverse is 1. So basically, to undo a fraction that's being multiplied to our variable, we're going to multiply by its inverse, right? This multiplicative inverse. So we'll see some examples of that in this video as well. So how do we solve a one-step equation? So in order to solve an equation, we have to isolate the variable and keep each side balanced. So we need to get the variable alone on one side of the equal sign. And we're going to do inverse operations to help us get to this point of solving the equation. Addition and subtraction go hand in hand, and then multiplication and division go hand in hand. So those are opposites, right? So if I add 5 and then subtract 5, I end up back at 0. If I multiply by 2 and then divide by 2, I end up back at 1, right? You end up back where you started. So inverse operations can be thought of as opposites or undoing each other. So I like to tell my students, so when you see this equation in front of you, whether it's a one-step, two-step, multi-step, first ask yourself, what operation is taking place? What is happening to my variable? Is there multiplication going on? Is there addition? Is there subtraction? Is there division, right? Eventually there's going to be exponents involved. For right now, just what operation is taking place? What single operation? And then what is the inverse operation of that? Because we're going to do the opposite to isolate the variable. All right, so let's take a look at some examples. So we're going to use inverse operations to solve each of these one-step equations below. And what they mean by one-step equations is that there is just one operation involved. So there's one operation that's happening to my variable, and therefore one step is going to be needed to undo that operation. The steps we apply with these one-step equations, those are going to be very important later on. So make sure, again, you are showing your steps. You're not just solving these in your head. And if you are solving them in your head, that's not necessarily a bad thing. Just know that you will want to understand how those inverse operations work, because eventually you're going to get to equations that are not easily solved in our head. But like I said, it's not a bad thing to have it in mind of like, oh, I know the solution for this first one's going to be such and such. So when you show your steps, make sure you're coming up with that solution that you mentally calculated, right? So for this first one, it says 4x equals negative 16. I like to draw a line through my equal sign just to kind of divvy up the left side from the right side. I think it's a nice visual, and I think for students it helps a lot. Again, it's totally optional. It's not something you have to do, but I know a lot of my students like to do that to just, again, keep things visually neat, and they can actually see what's happening to both sides of that equal sign. So that would be my first step. So 4x equals negative 16. Again, here's my variable. It is being multiplied by 4, right? There's no operation that is being shown in between this 4 and the x, but that is indicating multiplication. So what's the opposite of multiplication? Division. So we're going to divide both sides by 4. What happens here on the left-hand side, 4 divided by 4 makes 1. So we end up with 1x, or just x, equals, and then on the right hand side we can simplify this, right? Negative 16 divided by 4 is going to be negative 4. And then there's my solution. And then we can check it. We can either write it out or we can just mentally calculate. Is 4 times negative 4, does that equal negative 16? Yes. And so we know we solved it correctly. So for the second one, x plus 9 equals 13. Again, if it helps, draw that line just so you can visually see the left side of the equation from the right-hand side. And now we're going to undo what's currently happening to x. So ask yourself, what's currently happening to x? Well, there's an adding 9 here. What's the opposite? It is to subtract 9. And we're going to make sure we do that on both sides because, again, we want to keep this equation balanced. So positive 9 and a minus 9, that is going to cancel out and make 0. So I like to even just draw that 0 over it to show that it's gone. And what's left is now just x plus 0, or in this case, just x, equals, and then 13 minus 9 is going to be 4. And then there's my solution. And again, it's always a good idea to just take this solution and plug it back in and make sure that it actually makes a true statement. All right, moving on to number 3. So x minus 8 equals 4. So again, we're solving for x and we're showing our inverse operations. So subtracting 8, we're going to add 8 to both sides because, again, the opposite of subtraction is addition. Subtracting 8 and then adding 8 to it, that's going to cancel out and make 0. So I'm left with just an x on the left-hand side, and then 4 plus 8 is going to be 12. All right, moving on to the next one, number 4. So x divided by 5 equals negative 6. A lot of students look at this and they go, oh no, it looks like a fraction. But that fraction mark just means division. And the opposite of division is going to be multiplication. So we're going to multiply both sides by 5. And technically what we're doing, and I always tell my students, you don't have to write this out, but technically we're multiplying by 5 over 1. And what happens over here is that we're essentially cross-canceling, right? So, or if we didn't cross-cancel, right, 5x over 5, the 5s would divide out and make 1. Or if we cross-cancel, like I was saying, these cancel out, and now you're left with x over 1, or just x. And then on the right-hand side, we're going to multiply this out and do negative 6 times 5, which is negative 30. So make sure you're watching those negative signs. For my 7th graders, you are now in the world of negatives, and they are going to keep showing up. So just make sure you're keeping an eye on those. All right, number 5, x minus 6 equals negative 11. So again, ask yourself what's currently happening to my variable. Well, it's having the 6 be taken away from it. So the opposite of subtraction is to add. So we're going to add 6 to both sides. And then this minus 6 and plus 6 is going to cancel out and make 0. So we're left with x plus 0, otherwise known as just x. And then negative 11 plus 6 is going to be a negative 5. And then our last example on this slide, number 6, it says negative 2x equals negative 4. As a reminder, this negative 2 is being multiplied by x. When you don't see that operation wrote there, that is implying it's multiplication. So the opposite of multiplication, that's right, it's division. So we're going to divide both sides by negative 2. Again, this is going to cancel out here on the left-hand side. That's why we do that, so that we're left with just the variable, because again, we're trying to isolate the variable. And then negative 4 divided by negative 2 is going to be 2. All right, so that's going to be it for this video. Make sure you check out the next video related to solving one-step equations so that you can see more examples, including story problems. Thanks for watching.